Hello, hello, hello. Another installment of me blabbing on. Um, this is on. Let me get a pen. This is on calculating. Because we've done conditions for equilibrium, so we're going to calculate total force. Total forces. ES. That's wrong. Forces. It's meant to be forces, right? Forces. Total forces in horizontal direction and vertical. So in a previous thing we did this where we had that, and we had we had a force coming here, we had a force coming there. So this is Fy and this is Fx. Don't forget positive, positive, x-axis, y-axis. So we could have also have one coming up here as well. So we need to find out the total forces in the directions. These are straight up and straight across, nice and easy. But you may have one like this. So you may have a force coming here called F1. Or you may have a force like that. What we've got to do to these is break these down into horizontal and vertical components. Because this force here will have a horizontal and a vertical. So we've got to break that down into its horizontal and vertical components. Obviously I'm going to give you an angle as well there, right? So you need an angle. So a bit of trigonometry come in. If you can hear the banging, it's because they're doing the loft. But hopefully my microphone is stopping all that. So once we've worked out the horizontal and vertical forces, we can then work out a thing called the resultant force. Resultant force. Because we could have an object and it may have a force going this way, may have a force coming that way, and it may have a force coming that way. Now we have talked about equilibrium. So we have talked about things being equilibrium, as in the forces equaling each other, but that may not happen. So you get a thing called a resultant force, which is the resultant of them forces. And that will make this thing move. Resultant force. So this force here and this force here and this force here, if you add them all up, the resultant could be that this thing could move in that direction. That could be the resultant force with an angle. So that's what we're going to be doing today. Bit of trigonometry, but don't worry about it. So, new page. Now then. Resultant force. Resultant forces. So, we could have a force on an object like this. So, let's see if I get my little tool out here. Sort of. Let's get rid of this. So, we could have a force coming this way, horizontal, and we could have a force coming that way, straight up, vertical, right? So they're straight up. So this is vertical, obviously, and this is horizontal. So we can add them up. We know the total horizontal force, because in this case just one, and we can work out the vertical. We can add them up because that one's in the vertical direction, It's got no horizontal component, it's just going up. This one's going horizontal, it's got no vertical, because it's just going across. But if we've got a force like this, you know, we can't just add it up. We've got to work out the horizontal component and vertical component. So if I've got a force like this, and this could be something like kicking a ball, or let me get rid of that. So here's my force of, say, 10 newtons. And this is the horizontal. So this could be a rocket, it could be a football. Right? So let's just do that as well, get 90 degrees to it. So here's my force, 10 newtons. It's something being forced at an angle. So there's my angle. So it's a 10 Newton force at a certain angle from this horizontal. Now this force, right, has two forces that makes it the resultant. So this force will have a horizontal force. Make a bigger pen for you. So it'll have a horizontal component. It'll also have a vertical component. So horizontal component, we call that FH perhaps. And we can call the vertical component FV for vertical. So these two forces will result in this resultant force here. Resultant. And then here's the angle of direction. So all that really means is that, you know, I could, so this could be an object, right, and I could pull it this way, and I could pull it, I'd get off that. So I could pull it up, and I could pull it across at a certain force. So that's a Newton, and that's a Newton. So I could pull it horizontally and vertically, and the resultant force could be something like that, in that direction. So this, if this force is bigger, it's obviously going to go a bit more that way. So that 10 newtons is a resultant of that force and that force. So what we can do is, with this 10 newtons, we can break it down into its horizontal and vertical components. And there's the trick. So a bit of trig. So we're going to use sin and cos now, right? So let's get a pen. If I've got a force, if I've got, let's call it a force like that. We call it F. We call it F for our sake. It's the resultant force. Now that force is a resultant of this force here, which I'll say F horizontal. It's also a resultant of that force there. I'll call that F vertical. Just move my thingy-majiggy a bit more better. So there's my horizontal force, there's my vertical force, and here's my angle. Oops, what have I done, what have I done, Morg? No. Edit. Do. Whew. There's my angle. So this resultant force is a resultant of this horizontal and this vertical. Now we can work these out. We can work out the horizontal force, and we can also work out the vertical force. As long as we've got this, as long as we've got that, and we've got the angle, we can work these two out. Now you can scale draw it. If you drew that triangle, if you drew that line up at the length and with the angle you could do it that way. But we're going to use trig because it's a bit more accurate. So go back to my triangles. Here's my triangle. Here's my triangle. This here could be my resultant force there. Look, straight line like that. Not very good. And this is my horizontal, and this is my vertical. Here's my angle. So going back to trigonometry, this length of the triangle here is the hypotenuse. This side here is going to be, let's just call it hyp. This is horizontal, that's vertical. Forces now. That's my hypotenuse, and this is my angle. So this length of the triangle is going to be, anybody know, the adjacent. Right, and I could also put a dotted line like this. This is going to be my opposite. So to complete the triangle, because that's all it is a triangle. So here's my triangle. That's my hypotenuse there. And I'm going to draw a line down like this, and I'm going to draw down a line like this. So there's my triangle there. There's my angle. That's my hypotenuse. This is my adjacent. This is my opposite. Now, this side here is the same length as the opposite, because it's got to be in it. So this is my horizontal force here, which is the same length as my adjacent. This is my vertical force up here, which is going to be the same length as my opposite. So there's my right angle triangle, and this hypotenuse here is my resultant force. That's the force. So if I can work out the adjacent, Swiggerty, if I can work out this adjacent length, which I can because I know the angle, and I'm going to know this hypotenuse, I can use SOHCAHTOA to work out the length of this adjacent. That will give me my horizontal force. I can also use the same trick to work out this opposite side, which is the same as this side, which will give me my vertical force. I do need to know, though, I need to make sure I know the angle, and I need to know I've got the resultant force. Don't forget, the resultant force is really the hypotenuse. So if I've got the hypotenuse, which is going to be my resultant force, and I got the angle, I can work out using sin and cos this horizontal force and this vertical force. All I'm doing is working out the adjacent and the opposite. So here's my triangle. Let's go back to my little thing. All right. Here's my triangle. Ta-da! Get rid of that. There's my angle. Right, I'm going to give, so this is going to be now this is going to be my horizontal force, and this is going to be my vertical force, just like we sort of explained up there. This is going to be my resultant, I'll call it resultant force, right? It's a force. So I know this force, right? So I know that, and I know my angle. Because I'm going to give, you need to know this, and you need to know this to work out these. All right? So don't forget, this is the hypotenuse. This is the opposite, and this is the adjacent. So, trigonometry. So if I want to work out the opposite, bearing in mind I know the hypotenuse, so I've got the hypotenuse, I've got a value for that, right? You'll have a value for that, which can be the same as the resultant force. So we know this value. We also know this value, because I'll give it to you. If I want to find the opposite, that's the opposite side, which could be my vertical force. I know the opposite, and I know the hypotenuse. I'm trying to find the opposite, and I've got the hypotenuse. So I can use this. So I'm trying to find the opposite, and I know the hypotenuse. So I'm trying to use this and this. So I can do this. Sine of the angle, because I know the angle, equals opposite over hypotenuse. If I want to find the opposite, all I've got to do is bring this across. Sine of the angle multiplied by the hypotenuse equals the opposite. It's not 0, it's opposite. So I know the angle and I know the hypotenuse. The hypotenuse is my resultant force. I'll call that F, RF. Could call it F, right? So to find, now, let me go down a bit more. There. So sine of my angle multiplied by the hypotenuse equals the opposite, which I can write like this. So the opposite side, there's only trigonometry now, is sine of the angle times by hypotenuse. Now, the opposite is also the vertical force. All right. Sorry, the opposite is the vertical force, and the hypotenuse is the resultant force. So, different pair of pen. So, FV, just the length, equals sine of the angle times by the resultant force. Because my opposite is the same length as my vertical force, and my hypotenuse is my resultant force there. So if I've got a resultant force and I want to find the horizontal component, the vertical component, so a vertical component FV is going to be the resultant force times by sine of the angle. Write that down. That's what we need to know. So if I know the resultant force and I know the angle, I can work out the vertical. I can do the same thing. I can do the same thing for this. Right, so I'll rub this out now, so I've still got it. So we've done the vertical. I'm now going to work out the horizontal. Right? And the horizontal is going to be the same thing. I know the horizontal. I'm trying to work it out, sorry. I know the angle and I know the hypotenuse. So once I've done all this, probably a quicker way of doing that. So I'm trying to find now this length here. I know the angle and I know the hypotenuse. So I can use, alright, and now I know the hypotenuse and I know the adjacent. So I'm going to use cos. So cos of the angle is going to be adjacent over hypotenuse. Right, don't forget the adjacent is the same as the horizontal force and the hypotenuse is the same as the resultant force. I need to find the adjacent, so I'm going to bring the h over just like before. So cos of the angle times by h equals a. So a equals h times by cos theta. So the adjacent side is the hypotenuse times by cos of the angle. Alright, just trigonometry, GCSE stuff really. So now, let me do it, we'll just take it down here then. So, where shall I do it? So A equals h cos theta. Right, let me do it down the other way. So A equals h times cos theta. Now, that's the adjacent. This is the adjacent. This is the hypotenuse. So the adjacent is the horizontal force, and the hypotenuse is the resultant force. So I can do this now, just like I did with the other one. So horizontal force equals the resultant force times by cos of the angle. Right, so really that's all you need to know is that really. I've just gone through the trigonometry, because once you can do trigonometry you can do a lot of things. Don't know why I keep doing that. So the vertical force is the force times, so the vertical component is the resultant times sine of the angle, and the horizontal force is the resultant times by cos of the angle. I'll do an example to make it a bit clearer. Makes things a bit clearer then. So if I got a force, resultant force like this, 50 newtons, right, and it's right, so that's going to be made up of horizontal force, and it's going to be made up of a vertical force, FV is my angle. The angle we'll say is, I don't know, 22 degrees. So this 50 Newton force is coming up at 22 degrees. We need to work out the horizontal force, don't know, and the vertical force, we don't know. I mean, you could draw a line of 5 centimeters at 22 degrees and work it out like that. Scale drawing. But, so, the horizontal first, so FH, we know that FH is the resultant force times by cos of the angle. So, FH equals, right, the resultant force times by cos of the angle. So we know the angle. Don't forget this is the resultant force here. So to find the horizontal, all we've got to do is do 50 cos 22. So the horizontal force is going to be RF, which we know is 50, times by cos of the angle, which is 22. This will give us the horizontal force. So cos 22 equals that, say, times by 50. 46 and a bit. 46.036, eh? So the horizontal, so this horizontal force here is 46.36 newtons. That's it. F cos theta, resultant force cos theta, 50, resultant force, cos of the angle, 22. Right? And we also know then that the vertical force is the same, but it's going to be the force RF. Why does it do that? Makes me feel sick. Do it again. Sorry, viewers. Vertical force is going to be the resultant force times by sine of the angle. So this is going to be RF sine, sun going up, look, sine of the angle. So I'll do it down here. So FV equals the resultant force times by sine of the angle. So resultant force we know is 50 times by sine of the angle, which is 22. Always go from that horizontal, right? Always go, because if we look at the way we did it, we used this angle. Don't use this angle, because they swap over. So don't use that angle. Always use the angle I've given you. I mean, you can do it that way. It's just that you'll find that this becomes cos and that becomes sine. So to find the vertical force, we're just doing 50 times by sine 22. 18.73 newtons. Which means this force here is 18.73 newtons. Which makes a bit of sense because you've got more, the 50 newtons is closer to the ground and it's 22 degrees, so you've got more force coming this way. So what that really means is this. If that was an object, right, and you pulled it in this direction, and you pulled it in that direction, if you pulled it up, that's about 18.7, and you pulled it horizontally, 46. 46. The resultant force is going to be, it's going to go up like that, 22 degrees at 50 newtons. That's what I'm doing. I'm breaking down that resultant force into its components, horizontal and vertical. If you don't believe me, you could draw this triangle. You could draw a line 46 millimeters, draw a line 18.7 millimeters, draw a line 22 degrees, and it should be roughly 50, and then you could close the polygon. You could close that off. So you can scale draw it. Swig of tea. Oh, I don't know if you hear my belly rumbling. So that is called breaking down resultant, right, force into, still not getting used to my digitizer, horizontal and vertical components. So it works like this. If I had a force like that, I had an angle there, and I had that. You can do the same thing. Obviously, now you may have different directions, because this is going to be a minus direction. So you can still do it that way. This is still going to be F sine theta, if that's the force. And it's going to be F cos theta. You can do the same thing if it's like this. You've got force coming there with an angle. This is going to be F cos theta, and this is going to be F sine theta. Obviously, that direction now is negative, and this direction is negative. If you remember from equilibrium stuff. So this is all you need to know, is this. If I've got a force like that, I label the force F. And then this here is my horizontal component, HF. and this here will be my vertical component, HV. There's my angle. So this horizontal force is going to be F, remember, cos theta, and this vertical is going to be F. What are you doing? Stop. Edit, undo. F. I keep pressing the buttons on the pen. F sine theta. Sine going up. F cos. Obviously, don't forget, everything coming that way is plus, everything coming that way is plus, anything coming that way is minus, coming that way is minus. Alright, so that's what you need to remember. F cos theta, F sine theta. That's all you need to remember. I'll do an example. So here's my, is it going to work? Nope. Edit, undo. Here's my block. It's a block. So we've got a force, right? So let's say we've got a force coming up this way, 20 newtons. And we've got a force coming this way. Let's say 12 newtons. And we've got a force there. Let's do it over here. Make it a bit better. So we've got 20 newtons there. I also put a force here of 40 newtons there, look. And it's making an angle 32 degrees. So if I wanted to calculate now, right? Calculate total horizontal force. So I need to add up all the horizontal forces, and I need to work out the total vertical forces. So I'm going to do this now. So I'll do, so here's my F. Here's my FH. Here's my FV. Draw a table. If you add up all the forces, you will find any resultant force, right? So my first force is this 12 newtons. Don't forget, plus. My 12 newtons, right? It's going horizontal. It's going straight horizontal. There's no angle, right? So it's going to. So my horizontal force here is 12. It's not going vertical, so I'm going to put a note there. It's going that way, which we call negative, so I'm going to put a negative sign there. I'm adding up now. I'm adding up the total, so I can find the total horizontal and total vertical. So this 12 is going horizontal. It's got no vertical because it's not going vertical. I put a minus there because it's going in this direction, and that's minus. Next one, I got 20. The 20 is not going horizontal, but it's going vertical. So I'll put a 0 on a 20. It's going up, and anything going up, I'll put there. Nice and easy, huh? We need now to cope with that 40. It's 40 at 32. So we need to break that 40 down into horizontal and vertical, so we can put them in here. So where's my force? Is it 40, 40 and 32? 32 degrees there. We need to work out the vertical force and the horizontal force. Well, we know that FH is going to be F cos theta, and vertical is going to be F sine theta, because that's what we worked out up here. There, look. Right. F, we can call it the resultant force if you want to, because I've called it resultant force there, but it's still a force. So F cos theta and F sine theta. Now we know what the F is. The F is 40. Cos of the angle is going to be 32. Now the horizontal is going that way. Right, so that's going to be, I'll do it down here, look. It's going to be a negative number because it's negative direction, because it's going that way, look, which we call negative. So 40 cos 32 in your calculator, 40 times by cos 32 equals 33.9. I'm going to call that 34. Let's run a bit. 34 newtons, which means there's 34 there. It's minus because it's going in that direction. And then the vertical force is going to be F sine 32. This one's going up, which we call positive. So it's going to be 40 sine 32 equals 21.2, say. Make sure we get the right things. 21.2 newtons. So this is 21.2 plus. Ta-da! Ta-da! Right. So you could draw that triangle and it'd work it out. So now we've broken this down. So this is the vertical component. Sorry, the horizontal component, and this is the vertical component. So we need to add them up. So I'm going to put 40 in here. There's my 40, because we're talking about this force. The horizontal component of that is 34. Minus 34 though, don't forget. And the vertical component of that is 21.2. It's going up. Thank you very much. 21.2. So now, all we've got to do is to find the total. So to find the total horizontal force and the total vertical force, all you've got to do is add them up. So I'm going to add all these up, and then I'm going to add all these up. Don't forget the direction. So the total horizontal is going to be minus 12 plus minus 34. Close that. Minus 12 plus 0 plus minus 34 gives me minus 46. So the horizontal component is minus 46, which means it's going to the left. And the total vertical is going to be 0. So we'll have to forget that. So 20 plus 21.2. Obviously it's going to be 40. 41.2. So the total forces, so on this object, right, the total horizontal force, total horizontal equals minus 46, and the total vertical Make sure I'm right, you know. Yep. Total vertical is 41.2 newtons. So this object, so all them three forces, right, when you break it down, in the end it's being pulled horizontally 46 to the left, because minus, and it's being pulled up at 41.2. So what you can do now is, this is where it gets exciting. So horizontal, so we know horizontal plus, plus, negative, negative, which means the horizontal is 46, so it's going this way, 46, and it's going up 41.2. Because 46 is minus, and that's going to be, it's just going that way, and it's going up at 41.2. So this thing has been pulled up. Them three forces, the resultant is going to be 41.2 up and 46 to the left, because we worked it out by adding them up. The final thing we can do is work out, so obviously this thing now is being pulled up at 41.2 and across at 40.6, 46, so we can work out which way it's going to go now. It's going to go that way. Kappa T, so that's the resultant force. So we can work that out now. So 41.2 up and 46 across. We can work out the resultant because we know this from Pythagoras. So here's my triangle. There's my 46. Right. Now, this here is 41.2, isn't it? 41.2. That's got to be 41.2 because it's the same length. And then this here, you can join it up. This is my resultant force. So 46 here, look, and 41.2, just a triangle. That's all that is. I've just made the 41.2 over here to make it look a bit better. Triangles are all the same. That's the same as that. So this top line's 46 and this is 41.2. So now a bit of Pythagoras we can do. Let's go black. So I'll call this A, I'll call this B, and I'll call this C. There's more. I've made some videos on this Pythagoras, but you should really know Pythagoras. So we know that A squared equals B squared plus C squared. I'm trying to find A, and I'm trying to find A. So A squared equals going to be 41.2 squared plus 46 squared. The opposite of a square is a square root, so I can do this. 41.2 squared plus 46 squared. So in your calculator, do this. All I've done there, look, I've just B squared and C squared, and then to get rid of the square, you just square root it. So on your calculator, you can now do this. 41.2 squared, 41.2 squared plus 46 squared equals, don't like it, square root 41.2 squared plus 46 squared, 61. 61.75, 61.75 newtons. What that means is, viewers, is that the resultant force is 61.7 that way at that angle. You can work out the angle if you wanted to. So 61.7. So what that really means is this thing here is going to be, after all them forces, I'm going to make this bigger. All them forces are going to make this thing go up like that, something like that, at 61.7 at a certain angle, which we don't know yet. But we know the resultant force is 61.7 because we've added up all the horizontal, added up all the vertical, and used Pythagoras to work that out. 61.75 is the resultant force. So, is this thing in balance? No, it's not in balance because it's got a resultant force of that. It's not in equilibrium, it's going to be moving. 61.75 newtons. All right. That direction. Something like that. Getting a bit messy now. So that is an example of breaking down forces into horizontal and vertical components and working out the total forces and then working out the resultant force of them horizontal and vertical forces. It's easy when you've got a horizontal and a vertical, you can just add them up. But when you've got a angle, you've got to break them down, just like we did. Don't forget, practice makes perfect. Practice makes perfect. Repetition is the mother of skill. Repetition is the mother of skill. So practice, 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 and I will see you on the next video. North Star.